How's it going, Charles? Today we're going on to calculation of term, working from slides 39 to 41 from the Finance PowerPoint. Okay, so what we're going to be doing with this section now is we're going to be calculating N, okay, which is your time period or the number of payments. Now the problem with this thing is it's in the exponent, okay, except for simple interest. And we can't just, do our normal thing to solve for that exponent. So what I want you guys to know is we're going to be using logs, okay? Where if you've got something like this, a to the y is equal to x. And we want to get the y on its own, or in other words, solve for that exponent. This is going to be y is equal to log x base a, okay? And these are interchangeable. You can swap between the two. So that is how we're going to solve for this n, okay? And you'll see in a second how we do that. So this first example is saying, how long will it take for an investment to double at a rate of 5% per annum? Express your answer in years and months. So because this is an investment, we know it's going to be a compound formula. So we've got our A equals, P equals, I equals, and N equals. And I just want to write my formula. And you can see here that our N is in the exponent, okay? So they're asking us how long is it going to take for an investment to double? Well, what did we initially invest? Well, it doesn't really make a difference. We just want it to double, okay? So we're just going to make that x. Then our accumulated amount would be 2x because it's double our investment. Our interest rate, they told us, was 5%, so that's 5 over 100. And our n, we don't know. We're going to calculate the time period to double an investment. Just substitute our stuff into here. So we get 2x is equal to x, 1 plus 5 over 100 to the power of n. What I'm going to do now is just divide both sides by x, and we get 2 is equal to, this I'm just going to put on the calculator just to make it simpler. So we get 1 plus 5 over 100, and we get 1.05. Okay, now there is a 1 here because I divided through by the x, but I don't have to put that in there. Now, if you have a look here, this is what we want to solve for, and this is in this form, okay? So if you have a look here, our y is our n, so we can say that n is equal to log. Our x was the thing that it was equal to, so that's equal to over here, so we're going to put the 2. And our base, which is the a, is whatever that thing was raised to the power. Okay, so this is going to be 1.05 at the bottom like that. All right. We can just plug that straight in the calculator because you have this log button over here, this one over here. So log, our base is 1.05. And over here we put 2. Press equals, and we get that n is equal to 14.20669908. Okay, now this is in years. So you have 14.20669908 years. Okay, so I just want to write that 14 plus 0.20669908 years. Okay, I've just broken it up. The full number and then the decimal part. Now, grade 12s, we never talk about 0.20669908 years, okay? So what I'm going to do is I'm going to leave my full years, so that's 14 years, and I'm going to convert this years part into months. Now, how do you convert years into months? We just multiply this by 12, okay? So on my calculator, I'm going to get rid of that 14, by subtracting that answer by 14, and we're left with that decimal part. I'm going to take that decimal part and multiply it by 12 to convert it into months. And we get that. Now, what I'm going to do is I'm going to round it up to that next month, okay? Because that decimal part will be days, and we don't want to go as far as years, months, days, hours, minutes, and so on. We just want years and months. That's just sufficient. So I'm going to bump that up to 3. So this will be 14 years and 3 months. Okay. Going on to example 2. Example 2 is saying, just need to get it here. It's saying a loan of 50,000 Rand is repaid by means of equal monthly installments of 3,000 Rand, starting 1 month after the loan was granted. So that means that it is not present value in advance, it's just your normal present value. The interest charged on the outstanding balance is 12% per annum, compounded monthly. How many installments are required to repay the loan? Okay, so we know it's going to be a present value problem. So we have P is equal to, and we have the loan of 50,000. X is equal to the payments, which is 3,000. Our interest rate is 12%. And our N is equal to, we don't know. Okay. This I'm just going to divide by 12 to get it into the monthly interest. So we've got 12 over 100. Divide that by 12 and we should get 1 over 100. Okay, so I'm just going to write out my present value formula. So P is equal to X, 1 minus 1 plus I to the minus N all over I. Substitute all my values into the formula. All over 1 over 100. Okay, so you can see that this is going to be a log problem, because our unknown is in the exponent. Okay, so guys, I'm going to miss a few steps here, okay? But I'm going to be showing you on the calculator what I'm doing. Okay, so we want to try and get that thing on its own. So the first thing I'm going to do is I'm going to take the 50,000, multiply it by this 1 over 100, okay, to get rid of that denominator. So we've got 50,000 multiplied by 1 over 100, and we get that. Now I'm going to divide by 3,000, and we get that. Then you can see over here I've got this 1. I'm going to take the 1 to the other side and it becomes a minus. So I'm going to subtract 1 from this, and we get that. So now we've got minus 5 over 6 is equal to minus, I'm just going to work out what that is on the calculator, 1 plus 1 over 100, and we get 101, or decimal form 1.01 to the power of negative n. Okay, you can see that I can divide both sides by the negative, and we get 5 over 6 is equal to 1.01 to the minus n. I'm just going to rewrite our log law here. So we know if we have a to the y is equal to x, that means that y is equal to log x base a. And I'm going to put that into log form. So you can see here that our power, which is this, is now going to go to the front. So we get minus n is equal to log. The x is the thing that it was equal to, so that's 5 over 6. And then our base goes over there, which is 1.01. Okay, I'm going to work out what that is on the calculator. So we've got log 1.01, and then that's going to be 5 over 6. And we get negative n is equal to negative 18.3231658. Divide both sides by the negative, and we get n is equal to 18.3231658. Okay, so the next thing I'm going to do is work out how many payments that we've got here. So you can see that we've got 18 full payments. Of 3,000 Rand. Okay, because that's what your monthly payments were with 3,000. So we have 18 full payments of 3,000 Rand. Then we've got a fraction of a payment of 3,000 Rand. Okay, and that's our last payment. So if we have a fraction of a time period, it's not that full last period. Okay, so that won't be a full amount of 3,000. It'll be a fraction of 3,000. So what we'll have here is we'll have plus one final payment less than 3,000. Okay, so in total we have 19 payments, but 18 of them will be 3,000 and one will be less than 3,000. All right, so grade 12s, what I would like you to do is exercise 4.7, numbers 2, 4, 6, and 8, and then exercise 4.8, numbers 2, 3, and 4 for me, please. Thank you.